Hello, this is the genuinely approachable Sudoku for the 10th of January 2024. It is Days Like These by Bill Murphy. It is an arrow Sudoku, so let's go through the rules for that. Normal Sudoku rules apply, so the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along an arrow must sum to the digit in the bulb, so you have these little arrows here that point in different directions. Whatever you have on these like shafts of the arrow, they have to sum to the value in here. So if say this was like a 2, then this would have to be a 7 because these two sum to 7. Alright, and those are the rules. With that, let us begin solving. The first thing I see here is this 8 on this arrow, which is very interesting because this must be the sum of both of these, therefore it must be bigger than each of these components because none of these can be 0 or negative. So this value itself must be bigger than 8, must be bigger than this cell, and therefore must be a 9, which means this is always a 1. This 7 is the next thing to look at because, again, this must be larger than 7, but it cannot have a 1 in this cell because of that 1 existing already. So it must be, because this must be a 7, it's either 8 or 9. If it was an 8, that wouldn't work because that puts a 1 there, which means it must be a 9 putting a 2 there. This section looks very similar, in fact, because this must be 8 or 9 again, can't be a 9, must therefore be an 8, putting a 1 here. This cell is also a very interesting follow-up of this, because this must be bigger than 5, but can't be 7, 8 or 9. So it has to be a 6, putting a 1 there. Alright. Okay, so these ones look at these cells, which means that 1 goes into one of these boxes. However, we know 1 cannot be at the bulb of an arrow, because that means that these two cells sum to 1, which is, it's a little ridiculous because you can't have two digits at all from 1 to 9 sum to 1. So that can't be 1, meaning 1 is over there. Okay. Well, these 8s look at these cells in this box, so that's an 8. Does 9 do the same thing? Not really. I guess this 6 looks at those cells. So 6 is one of those cells, and this 6 sees that, so 6 goes there. Alright. Right here. Those cells are seen, so 6 goes in one of those cells. Right, okay, where does 7 go in this box? Because all of 8 and 9 are all above 7, you couldn't have 7 be on an arrow, because then you couldn't put 8 and 9 on the bulb, meaning that 7 cannot be on the arrow shaft. 7 can't be here either, meaning 7 goes there. Okay. We have 2, yes, and 2 sees those cells, which means that 2 is in one of those cells. But 2 can't be there as well, because that would have to put a second 1 here, which just isn't possible. So 2 can't go there, 2 goes there, which is next to a 5. And these cells are 3 and 4, in which case 4 has to be 3 plus 1. Okay, that is a lot more progress. These cells are just 3, 5, and 6, I think. This can't be 3 or 5 in the column, so it's a 6. Yes, alright. Okay, these cells are... Sorry, a bit... I was a bit... 4, 7, and 9. Wow, okay. This can be 7. This could be anything, actually, I think so. Yeah, okay. Wait, did I remove the wrong digit? Yeah, I meant to remove a 7. Oh, the 4 here also sees that, so that is just a 9, okay. And therefore those cells are a 2, 5. This 5 sees that, so 5 goes... No, sorry, not 2, 5. What am I saying? It's 2, 9. Ah, and that is resolvable, because 9 can't be on the shaft. This would have to be way bigger otherwise. So this is a 2, this is a 9. That places an 8 here. By the similar logic, this digit must be greater than 5. It can't be 6, 8, or 9, so it's just a 7, meaning 2 goes there. This 7 sees that, so that's a 4, that's a 7. This 3, 5 remains unresolved. 4 in this box, this 4 sees those cells, so that's a 4. Those are therefore 1 and 3, I think. Yes, and this 1 sees that, so that's a 3, that's a 1. This 3 sees that, so that's a 5, that's a 3. These cells are now, I think, 1 and 8. This one sees that, so that's an 8, that's a 1. Actually, this 1 and 8 could be disambiguated even without this 1 or 8. And there's a bit more interesting logic with that, but I'm not going to go through that because I think that's decently more on the bifurcation side. What do we have here? 4, 5, 9? 9 is not in this cell. And 5 is not in this cell. Well, 9 clearly can't be on the shaft either for reasons we have discussed, so that can't be a 9, that is a 4, meaning that is a 5, that is a 9, which is true because 5 is indeed 4 plus 1. Those are 2, 6, and 7. That can't be 7, that can't be 6. These cells are, well, 3 sees those cells, so 3 goes there. Those are 2 and 4. That 2 sees this cell, so that's a 4, that's a 2. This 2 sees that, so that's a 7. Okay, what are those cells? 1, 5, 8, I believe. Okay, we get some chocolate teapot going on here because each of these cells has a different digit removed from it, which is not very helpful. Okay, I don't think we look at this, I think we look at other things right now. For example, those cells have to be, I think, 3, 4, and 5. 3, 4 sees those cells, so that's a 5. This is a 3, 4. 4 sees that, so that's 3, that's 4. Okay. I mean, I guess we can do the same here. What are those cells? 2 and 7, which is disambiguated by that, so that is 7, that's 2. These cells are 3, 5, 9. Okay, well, I mean, 9 is removed from that cell. That cell is not a 5, that is not a 3, but again, 9 cannot be on the arrow shaft, so that's a 3. That's a 5, and that is a 9. This checks out. 2 plus 3 is indeed 5. Those are 1, 8, 6, I think. Yes, 1, 8, 6. So another one of these. 6 can't be there. 8 can't be there. 1 can't be there. Another chocolate teapot, I guess. I guess we have to look at these 2 arrows for the last disambiguation. Let's do some more regular Sudoku. Where does 9 go? Yeah, these 9s see... Well, they see a lot, but they don't see enough, I think. No, they don't. Oh, they really don't. Okay. 4s. 4s are one of those cells. That is useful. I guess 3 as well, actually. Those cells are not 3. 3 sees that. So that is 3 and 4. Which means that this is, in fact, just a 7. This is 1 or an 8 by the row. And can't be 1. So that's 8. That's 1, which resolves this. This 8, yes, also resolves that. So that's a 5. That's a 1. That's an 8. 3, 4 not yet resolved. Those are 1 and 1, 9. This one sees that. Those cells are 2, 5, 6. 2, 5 sees that, so that is 6. 5 sees that, so that's a 2, that is 8, 5. And now here, you can see those cells are 6 and 7. 7 does see that, so that's 6, that is 7. These cells are, well, 2, 3, and 4. Right, and we can see that, the only pair here that adds to 6 is 2 and 4. In fact, you can't have 3 on this arrow because the other digit would then also be 3, which fails. So that is not 4 anymore. Yeah, that's not a 4, that's a 3. That's a 4. These digits are, I believe, 3 and 9? 3, 9? Yeah, which is resolved by this 9 over here. So that's a 3. That's a 9. This 6 resolves that. That's a 2. That's a 6. This 2 sees that, so that's a 4. That's a 2. Solving the puzzle. Alright, well, this was really cool. Yeah, I actually really enjoy arrow puzzles. Just normal arrow puzzles. They have pretty interesting logic to figure out, especially the single digit ones. The ones with double digits are way harder. But if I ever do a puzzle like that, I'll probably try and figure it out. Until then, I hope you enjoyed this video. I'll see you. Bye bye.